Good day to the examiners. My name is Celina Cheak Mei Min. In this video, I am going to present my final year project which titled as The Effect of Hand Dryer Fan Parameter on Noise and Aerodynamic Level. In general, hand dryer noise in the workplace can cause hearing discomfort along with stress and distractions to the workers. According to Berkowitz 2015, prolonged exposure to high airflow hand dryer may lead to noise-induced hearing loss. While according to Becker and Levy 2003, loud noise such as the hand dryer noise may cause stress and distract workers from staying focused in their job. The first objective is to investigate the existing default design of the hand dryer model. The second objective is to analyze the correlation between the input parameters and the response, while the third objective is to suggest the best combinations of input parameters that gives the optimum response in order to obtain the best results. The flow of the project starts with the problem statement and then determine the objective and scope of study. The input parameters, also known as the factors, are including the type of nozzle design and the type of insulation, while the data collection focusing on collecting the output responses, which are the air velocity, drying time, and the noise level. After the data collection has completed, the design of experiment DOE begins by analyzing the output responses using the full factorial design. Once all three of the responses have been analyzed, optimization of parameters take place, and the optimized parameters will be validated through actual experiments. Once the result of the optimization is validated, conclusion can be drawn. Otherwise, repetition of steps starting from the data collection will be needed. The type of field strategy used in this project is the design of experiment DOE by implementing the full factorial design. The factors involved are the type of nozzle design and the type of insulation, while the responses are the air velocity in miles per hour, drying time in second, and the noise level in decibel. Since there are two factors with three responses, thus it contributes to a 3 to the power of 2 full factorial design, which gives a total of 9 runs of experiments. The software used to conduct the DOE is the Design Expert software. From the table on the left, there are 3 levels in each input parameters. The type of nozzle design consists of 3 types of nozzles, which are the chrome nozzle, concentrator nozzle, and diffuser nozzle with numerical values of 0, 1, and 2 respectively. While the type of insulation consists of 3 types of insulations, which are the egg carton, wedge foam, and pyramid foam, with numerical values of 0, 1, and 2 respectively. Next, the experimental tools and apparatus used in this project are the Eco-Air hand dryer model, airflow anemometer, sound meter, and stopwatch, which are both software applications that can be found in the smartphone. For the experimental setup, there are 2 rounds of experiments that have been conducted. The first round of experiments shown in the left is the default setting of the hand dryer with its original state, while the second round of experiments shown in the right is the experiment prior to DOE, which involved the use of nozzles and insulations. The figures above show the installation of insulations in the internal motor housing and cap of the hand dryer. The type of insulation used in level 1 is the egg carton, while level 2 and level 3 use wedge foam and pyramid foam as the insulations. Table on the left shows the data collection from the second round of experiment. There are a total of 9 rounds of experiments provided with different combination of input parameters. It can be observed that the output responses of each round of combination are different from one to another. The table above shows the design summary of the full factorial design. The design summary shows that the type of study is factorial design, in which the initial design is in terms of full factorial, while the design model is a reduced linear. The total number of experiments is 9, which also gives a total number of 9 observations. There are 3 responses, which indicated by Y1, Y2, and Y3 for the air velocity in the units of miles per hour, noise level in the units of decibel, and drying time in the units of second. From the data collection obtained during the experiment, it can be summarized that the minimum air velocity is 21.18 miles per hour, while the maximum air velocity is 46.07 miles per hour. As for the noise level, the minimum limit is at 76 decibel, while the maximum limit is at 82 decibel. Whereas for the drying time, the minimum limit is at 10.43 seconds, while the maximum limit is at 18.6 seconds. Based on the data collected, suitable models are assigned to each responses for their respective analyses, which are suggested by the Design Expert software. In this case, the suitable model suggested for the first response, Y1, which is the air velocity, is the quadratic model, while the suitable model suggested for the second response, Y2, which is the noise level, is the linear model. As for the third response, Y3, which is the drying time, the suitable model suggested is the two-factor interaction 2FI model. As for factor A, which indicate the type of nozzle design, the factor is set at 3 levels in which the low actual is 0, indicating the chrome nozzle, while the high actual is 2, indicating the diffuser nozzle. While for factor B, which indicates the type of insulation, the factor is also set at 3 levels in which the low actual is 0, indicating the egg carton, while the high actual is 2, indicating the pyramid foam. Figure on the left shows the 3D surface plot for the factor's type of nozzle design and type of insulation with response to air velocity. It can be observed that the highest air velocity is obtained when the type of nozzle design is 0 and the type of insulation is 1. This also indicates that the type of nozzle design is the chrome nozzle, while the type of insulation is the wedge foam. Thus, this can also be considered as the best possible combination of factors that is able to achieve the most desirable output response, which is the maximum air velocity at an approximate value of 45.7975 miles per hour, according to the solution 1 suggested in the table below. Figure on the left shows the 3D surface plot for the factor's type of nozzle design and type of insulation with response to noise level. It can be observed that the lowest noise level is obtained when the type of nozzle design is 0 and the type of insulation is 2. This also indicates that the type of nozzle design is the chrome nozzle, while the type of insulation is the pyramid foam. Thus, this can also be considered as the best possible combination of factors that is able to achieve the most desirable output response, which is the minimum noise level at an approximate value of 77.165 decibel, according to the solution 1 suggested in the table below. Figure on the left shows the 3D surface plot for the factor's type of nozzle design and the type of insulation with response to drying time. It can be observed that the shortest drying time is obtained when the type of nozzle design is 0 and the type of insulation is 2. This also indicates that the type of nozzle design is the chrome nozzle, while the type of insulation is the pyramid foam. Thus, this can also be considered as the best possible combinations of factors that is able to achieve the most desirable output response, which is the minimum drying time at an approximate value of 10.7415 seconds, according to the solution 1 suggested in the table below. Figure above shows the ramp function graph in order to achieve the requirements for maximum air velocity, minimum noise level, and minimum drying time. The upward slope for the air velocity indicate the desired response at the maximum value, whereas the downward slope for both the noise level and drying time indicate the desired response at the minimum value. The minimum type of nozzle design 0 and the type of insulation 1.34 produce the highest air velocity, lowest noise level, and drying time with the desirability of 0.9. Figure on the left shows the contour plot obtained after optimization. Based on the desirability plot, the prediction value of the desirability after optimization is 0.9, while the optimization of air velocity plot shows the prediction value of 45.8 miles per hour after optimization. On the other hand, the optimization of noise level plot shows the prediction value of 77.16 decibel, while the optimization of drying time plot shows a prediction value of 10.74 seconds after optimization. In order to test the optimized parameters, validation through actual experiment is carried out by using the combination of wedge foam and pyramid foam as the insulations in the internal motor housing and cap of the hand dryer, while the type of nozzle used is the chrome nozzle. The results obtained shows that there was a slight reduction of 0.53 miles per hour in terms of the air velocity, whereas for the noise level and drying time, there were great reduction of 8.33 decibel and 4.24 seconds respectively. In conclusion, in terms of the first objective, which is to investigate the existing default design of the hand dryer model, the outcome of the first round of experiment has given average readings of 47.72 miles per hour, 85.33 decibel, and 14.87 seconds for the air velocity, noise level, and drying time respectively. As for the second objective, which is to analyze the correlation between the input parameters and the response, it can be concluded that the combination of the diffuser nozzle and egg carton has given the least desirable output. On the other hand, the combination of chrome nozzle and wedge foam has contributed to the most desirable output, while the combination of concentrator nozzle and pyramid foam has a fairly mid-range output. As for the third objective, which is to suggest the best combinations of input parameters that gives the optimum response in order to obtain the best result, it can be concluded that the best combinations are by using the chrome nozzle as the nozzle, and also the wedge foam and pyramid foam as the insulations in the internal motor housing and the cap of the hand dryer. From these three combinations, the result obtained has been validated, which gives the final reading of 47.19 miles per hour in terms of the air velocity, 77 decibel in terms of the noise level, and lastly, 10.63 seconds in terms of the drying time. And that is all from me. Thank you.